Okay, so we're going to have a look at another question from the 2022 HSC Standard 2 Maths paper. This question also appears in the advanced paper. So this is question 30. We're told Eli is choosing between two different investment options. Deposit a single amount of $40,000 today, earning interest of 1.2% per annum compounded monthly, or option 2, deposit $1,000 at the end of each quarter, earning interest of 2.4% per annum compounded quarterly. We're given a table of future value interest factors for an annuity of $1. We're asked to determine what is the value of his investment after 10 years using option 1, then to find the difference. Okay, so using option 1, this is just going to be essentially compound interest, right? So we're going to say A is P times 1 plus the rate to the number of periods. P is 40,000 times by 1 plus the rate, which is 1.2% per annum, but that's compounded monthly, so we've got to divide it by 12. So 0.012 is a decimal divided by 12, all to the power of the number of years, which is 10 years, multiplied by the number of months in a year. So this is 120. So we can put this whole expression into our calculator. We get 40,000 times 1 plus 0.012 divided by 12 is 0.001. 001. And this is to the power of 120. My calculator tells me this is $45,097.17 ... So we have to round this to dollars and cents. So therefore this will be 17 to the nearest cent. And this is the answer for part A. Now we'll have a look at part B. What is the difference between the future values using option 1 and option 2? Well, now we need to calculate the future value of option 2. So $1,000 at the end of each quarter, earning 2.4% per annum compounded quarterly. That means in our future value table, the rate will be 0.024 divided by 4. It will be 1/4 of the full yearly rate because it gets compounded quarterly. This is 0.006. This is the rate. The number of periods is going to be the number of years, 10, multiplied by how many quarters there are in a year, which is 4. This is going to be 40. This is going to be the number of periods. So rate 0.006, number of periods 40. That's 4505630. So this means the total of the annuity, we'll call this A2, is going to be 45.05630 multiplied by the annuity deposit amount, which is 1,000. So this is $45,056.30 to the nearest cent. So this is how much you would get if you put it into the annuity as opposed to into the single amount deposit. We are asked to find the difference. So the difference will be the first one minus the second one, 45097.17 minus 45056.30. So therefore the difference between the two, 45097.17 minus 45056.3. My calculator tells me this is $40.87. $40.87. So this is the difference. And this is the answer that we're after for part B. Now all of these amounts, by the way, you could denominate these as dollars. Often when we do financial mathematics, they don't get denominated as dollars right until all the calculations are done. But you could choose to denominate your answers in dollars. It's not really going to matter. So let's talk about the marking. For the first part, 2 marks. We get a mark for writing an expression for the future value. So essentially, if you start working with compound interest formula or something equivalent, this will get you 1 mark. The second mark will be for the solution, correctly rounded. For part B, for 1 mark, you will have to calculate or use the future value table. So find the correct interest factor or start using that to do the calculation somehow. And then for the 2nd mark, you'll have to find the correctly rounded difference. So this is how this question works.